All right, everyone. Welcome today to the DBA Fundamentals presentation, Development Lifecycle Basics for DBAs. And I'm going to stop the transcription before it drives me nuts. All right. So with that, obviously today's speaker is Ethan Blumen. As you've probably heard him 1,000 times, if not more, he is the man, the myth, the legend. And I'm just sitting here prettily behind the screen. Today is March 21st, 2023. In the top right-hand corner of the screen, hopefully you can see the three leaders of the DBA Fundamentals group, Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. If you need to get hold of us for any reason, the easiest way probably to get hold of us is using our Twitter handles, which is to the right-hand side of our names. Below our names, you can see the various ways of getting hold of us on social media. The first one on the list is meetup.com, where probably most of you actually found us in this group in today's presentation. Below that is one of my favorite websites, dbafund.org, where we have all of our archives and all of our upcoming presentations out there for viewing pleasure. Below that is one of my favorite video sites on the web as well. It is dbafuntube.com, where we have all of our past presentations, so you can view them at your leisure. We have, at this point, I think it's 12 years of presentations from various people. That's always fun to look at, and you'll always find something new pretty much every time you look through there. Also below that is our Twitter handle at DBAFun, our Slack channel, where we talk about various things with DBA stuff and other SQL related topics. And also below that is our LinkedIn group. Session recordings. Most of our sessions are recorded and usually available within 1 to 2 days. If you check out our YouTube channel, dbafuntube.com, you'll see us there. So be sure to like and subscribe so that you know the very second we put it out there. So you can have all kinds of fun and relive the moments of joy with Edwin here. Please be sure to turn off your camera and to mute yourself. I'll actually be turning off my camera here in a few minutes so that you can enjoy listening to Edwin talk about all kinds of goodness. And be sure to tap into the chat if you have any questions. And here is Ethan's wonderful list.
You can skip that. You can skip it. I have a slide.
He has even more, even better. So with that, then I am going to stop my little part of the presentation so you can enjoy it and see all of his goodness. So with that, over to you.
Thank you, Kevin, and thanks for having me here. Let me share my screen. Where's the little screen? Where's the mini screen? Oh, there it is. Okay. I go like this. Okay, that's weird. Hang on a second. I want to see where's the mini screen for the Teams meeting. That's weird. Okay, never mind. I'll do it without it. Okay. Right. Okay. Thank you for having me again. And my name is Eitan Blumin, and this session will be about development lifecycle basics for DBAs. A few words about me. I'm a SQL Server consultant since, I think, 2005. I've been working as a senior DBA consultant at Madeira Data Solutions since 2010, and since I think 2019, I'm also a DBA team leader at Madeira Data Solutions. Madeira Data Solutions is the leading consulting company in Israel for the Microsoft Data Platform in general and SQL Server specifically. We provide various services, consulting services, professional services, training services, remote managed DBA services, and so on. I also co-host the SQL Server Radio podcast together with Guy Glanzer, who is the CEO of Modern Data Solutions. On the screen, you can see my various places where you could find me, my blog, the podcast on Twitter and LinkedIn. And I'm also Microsoft Data Platform MVP since 2020, I think, if I recall. Right. So a few words about this session. What is this about in general, and who is it for? Who is the target audience? So nowadays, more than ever, and it becomes more prominent as time goes. I see it in the field, in the customers we're working for, and fellow DBAs, where the implementation of Agile and DevOps methodologies becomes more and more prominent, more and more common. And the same methodologies, they are also creeping faster and faster towards our neighborhood of DBAs, our own fields and profession. And so the purpose of this this session is to prepare you for that, essentially, which means to get you familiar, introduce you to this world, the terminology of DevOps and development life cycles, what it means, various commonly used terms and buzzwords such as artifacts, unit tests, CI/CD, and so on. The target audience for this are DBAs who are about to enter this world and start working in agile methodologies and start dealing with DevOps, or for DBAs who just recently started doing it, perhaps because they were forced to by the organization or because they thought it was important, and they just they're not entirely they don't yet get the full full understanding of what is going on around them and what is the meaning of all of these weird sounding terms. And yeah, so and also this session is basically part one of a series of sessions. So Development Lifecycle Basics is part one of the series. There are, as of right now is March 21st, 2023. There are 4 parts in total. This is the first part, whose purpose is to, as I said, get you on the same page, essentially, in terms of terminology and basic concepts, and introduce you to this world of DevOps and what everything means. So in this session, we'll talk about why database, specifically database DevOps, is important. Why should we care about this thing? And we'll touch upon basic terms such as source control, unit tests, CI/CD pipelines, and if time allows, then we'll also talk a bit about SSDT and how it helps you integrate into that world. Right. So why do we need database DevOps? So in order to understand why we need it, we first need to understand where we were until now. So once upon a time, the classic DBA toolset looked something like this, like a vintage car, old vintage car, which sometimes, often, it was custom built or maybe custom maintained. You know, the person who's the owner of this car would add stuff to it on its own, improve it on its own, tune it a bit here, a bit there, basically maintain it on their own. It got the person from A to B, it drives, let's say, and the owner would normally be closely familiar with the deepest inner workings of this car and how to fix the engine and tune what's it called, the gear shift thing, whatever it is. However, despite all of these things that I said that superficially sound good, it is still an old and outdated car, and it takes too much time from the owner's hands to use and maintain it. It's slow, it's cumbersome, it's not very productive. And most critically and most important, it is heavily prone to user error. And all of these points that I listed, the same thing is true about how DBAs, or how the classic DBA would work with database, with database in terms of development and deployments. Custom built, it works. Basically, the DBA would have to be closely familiar with how the deployment and development mechanisms work. Whatever these mechanisms are, they are likely old and outdated, and it takes too much time from DBA to use and maintain, and it is heavily prone to user error. What do I mean by all of these things? Basically, I'm talking about, let's say, the tool set of the DBA, which would include the main development tool. Often it is SQL Server Management Studio, SSMS. If we are talking about source control, that would usually be, if anything, it would be the DBA's workstation, or maybe some kind of shared file server, or God forbid, live production database, or maybe a live development database, which is the least preferable situation. If you're talking about version history, it could be something like Dropbox, or OneDrive, or Google Drive, if anything at all. If there's something that saves history and version history of files, that's like okay, like the minimum, I guess. Okay. And if you're talking about unit testing, most DBAs, or rather classic DBAs, they don't even know what it is, what it means. It usually doesn't have anything to do with them. If you ask them about unit testing, they will say, that's not my department, that's QA over there, down the hall, right? And similarly, if you're asking them about CI/CD, they would like, I don't know what that is. You're talking about integration, about deployment. That's me. That's my job description. I'm the one doing this thing. I'm the CI/CD, whatever that is. You with your weird millennial buzzwords. Meanwhile, on the room next door, we have the software developers, whose worlds and toolset rather looks a bit different. It looks on the way other end of the spectrum, and soon looks like something futuristic from like the Enterprise in Star Trek or whatever, where they get all kinds of mechanisms that give them early error detections. They get automated testing tools, automated integration processes, automated deployment pipelines, collaborative development tools, and all kinds of cool toys and extensions and plugins and templates and AI like Copilot or whatever it is. Very futuristic, very advanced. And in practicality, this would mean things like Visual Studio as their main development tool, or maybe VS Code, or maybe other IDEs outside of the world of Microsoft, like I don't know, Eclipse or Toad, or sorry, Toad, that's for data DBAs. I don't know, whatever that is. There are all kinds of IDEs. I'm not going to go into that. So they get things like source control. They get version history as a result of being in source control. They get unit testing. They get CI/CD pipelines, and all of these good. They can enjoy it freely and happily, and everything is very futuristic and productive and effective. And that's the software developer toolset. But why can't we get all of those good things? Why can't the DBA enjoy all of those same tools, the same level of advanced technology. Well, it turns out that this thing in front of us, this database, where a bunch of entities and a bunch of programs and applications and web services and APIs and processes, they all connect to this thing and they depend on it. And in terms of dependencies and coupling, the database becomes a very critical component in the environment of your organization. And you know, this thing here is actually important, right? So when we want to do something to it, we need to be very careful not to, to ruin anything. And the reason we want to be careful is because, unlike software development, software applications, services, whatever it is, databases have a state that must be maintained at all times. And that state is actually the data. It is the base for the data. And that means that any changes that we do, any automations that run against this database, they need to take that into consideration and keep the state of the database, of the data, as it is. And that can be challenging sometimes. Also, in terms of paradigm shifts, when we're talking about DevOps, Agile methodologies, and all of those futuristic tool sets and methodologies that software development teams have, it usually means going from individual developers to a team of developers. It means going from big and difficult and infrequent deployments to small, frequent and easy deployments. And this these sort of paradigm shifts is also something that we tend to see more and more recently in DBAs and database developers as well, because we would want to implement Agile methodologies there as well and enjoy and reap the same benefits, reap the same fruits. And that means more effective development, faster time to market. It means less error. It means, as I said, smaller and more frequent deployments. But as I said, database DevOps specifically is hard because of the state of data. But it's hard, but it's not impossible. And despite all of these difficulties that I listed, we do want to be there. We do want to overcome these challenges, and we want to implement DevOps methodologies with with SQL databases as well. So what does that mean? That means that let's set up our end goal, okay? The way we want to see our desired end state, right? How we want, where we want to end up. And what does it mean, DevOps, right? And CI/CD. So what it means, DevOps and CI/CD, basically, essentially, in general, it means something like this. There's some kind of a developer, and the same thing is true for software developers and database developers, the same. The principles are the same. So we have a developer who develops, and whatever they develop, they commit to some kind of source control platform where they have version history and branching maybe, and so on. From that source control, there would be some kind of automation that would perform automated builds, automated tests, and once these automated tests are successful, we could also have automated deployment. And this, in a nutshell, what it means to implement DevOps. And the same thing that you see here, we would want to also implement for our SQL databases. What are the benefits? So as I said, we have earlier error detection. We have less errors in production. we have faster deployments, we have more consistent and reliable deployments, and overall, our processes, our development, sorry, or our database is less prone to human error. These are the technical benefits, right? These are the benefits to you as a SQL developer, perhaps, but it also has very direct implications on the business as a whole. And the next section that you're going to see, that would be relevant to, let's say, upper management. If you as an individual contributor want to start working in DevOps methodologies, but you see some kind of resistance and naysayers from upper management, you're going to have to work hard to convince them. And usually it involves telling them the following. Listen, once we get all of these things on the left-hand side, we get faster time to market. We have less production failures, which impact our end users. We have better availability, which also impacts our services and our end users and our reputation. We have less time wasted, and less time wasted means less money wasted, and less money wasted means more money earned. So if that's the sort of language that perhaps that would be probably more effective towards upper management, who usually prefer to look at the bottom line. Bottom line, it is profitable. It may be difficult to implement at first, and there is some kind of learning curve, but the benefits are significant, and it's worth the effort. So, with that being said on what is DevOps and why is it so marvelous, let's get to the nitty-gritty. So let's dive into basic terms, starting with Git source control. What is source control? What is Git? So I will focus on Git in this specific sessions simply because it is the more popular one. There is a paradigm shift going away from, let's say, TFS source control and into Git, also supported by Microsoft themselves. So I will not waste too much time on TFS. I'll focus on Git. Right. So what is Git? In a Git source control, you have a shared repository, which is somewhere maybe on the cloud or some kind of enterprise server. And you have a local repository that would reside on the local workstation of each developer. And there will be some kind of process where at first, as the first starting step, the developer would do something called a clone. They would clone from the shared repository to the local repository, which basically means downloading the whole branch, and I'll soon talk about branches. But basically cloning the thing, right? Cloning the whole repository, the whole source code. And then they would work locally on their workstation using some kind of IDE, which means integrated development environment, such as Visual Studio or VS Code or Azure Data Studio. And they would do things, they would develop, they make changes, they would commit, and each commit is basically, let's say, a unit of work, which represents something, some kind of change. I added a column, I improved performance, I modified an index, whatever. Each commit is some kind of unit of work with a message that describes what it is, what it contains. It could also contain changes to one or more files within a single commit. So once the developer performs one or more commits locally to the local repository, they will be ready to perform a push. A push basically means all of the commits that I committed and did not yet push them now, which basically means upload to the shared repository. And once you do that, all of your commits or all of your changes are now visible at the cloud, right? At the shared server, the shared repository. And now other developers, or maybe you yourself on another machine, can access these commits from the shared repository by performing a pull. which basically means download the new commits since the last time I pulled or cloned the repository. So now let's talk a bit about this purple looking shared repository thing. What is this thing at all? So in Git or source control in general, we have something called branches. Branches are basically a snapshot of your project where, let's say, we have the blue branch, which is our origin, right? We start from the blue branch, which has some kind of state of your project, and then we do something called a split. From that branch, we split into a new branch, which is the purple one on the screen. And then on the developer, the work that they do against this new branch, this new split purple-looking branch. And they say they do commits, as I said before, and they push their changes. Did someone unmute? I'll ask everyone to mute, please, if there are no questions. Thank you. Right, so once the developer finished developing, they did all the commits and pushes. Now they are ready to do something called a pull request. And a pull request basically means the developer now confirms that whatever the changes they made in the new purple-looking branch are complete, and they are ready to be merged into the origin branch, which is the blue one on screen. And the pull request, once you create that, it basically starts a discussion, some kind of back and forth between the developer and whoever is responsible for reviewing and approving the pull request. And that could be like a team leader or product manager or, I don't know, DevOps engineer or whatever, whoever was assigned to do this thing. It could, during that pull request, there could also be automated checks. Let's say behind the scenes, just because you created your pull request, there's some kind of automated process behind the scenes which is building your project. And if the build is not successful, that means you failed the check, and now you cannot merge your pull request. For example, there are all kinds of checks and automated checks that can be implemented. I'm not going to go too deeply into that at this stage. So let's say, okay, there were all kinds of checks. The reviewer has approved everything and says, yep, that's good. The new code that you submitted looks okay. I'm allowing you to merge those changes into our main branch. So now the reviewer approves the pull request and performs a merge. And now the changes are merged from the split branch to the origin branch. And this, what I describe now, is very, very high level in terms of working with branches. These are branches, okay? But there can be all kinds of branches. Every organization would normally have a different branching policy, okay? What you see on the screen is the description of something called Git flow branching policy. And Git flow is famous for being very strict, okay? Every branch has a very strict purpose, and the branching policy is very clear and very strict, and there's a relatively high number of branch types, which I'll go over in a sec. If you understand this, you will find it much easier to understand other, let's say, competing policies, such as the GitHub policy with that, or the trunk policy, and all kinds of other policies. They normally have fewer branches. Normally there are simpler policies. So the Git flow is a strict policy. It makes it. It's very safe. It makes it very safe in terms of early error detection and such, but it's also very difficult for developers to propagate changes from development to production, although that is on purpose. That's the whole point. If it's difficult to propagate changes, it will also be difficult to propagate errors and mistakes. Right. So in Git flow branching policy, we have a few standard branches. And these branches, except the last two, the feature 1 and feature 2, these are standard names, like the main, hotfix, release, develop. These are standard names, well known, widely known in the Git flow branching policy. So the main branch would normally reflect what is currently in production, in your production environment, in practicality. And the hotfix branch would normally be for urgent fixes that need to be done as soon as possible. Oh man, sorry. The hotfix branch would be reserved for urgent fixes that need to be deployed as fast as possible to production, and they cannot wait for the version which is currently in development. And that would be the develop branch, the blue one, which represents the overall version at the either organization or maybe the team level or maybe the system level, whatever the repository represents. Okay, it is the current version in production. In development. I apologize. That's the develop branch. From that develop branch, we would have feature branches split from it. And developers would only work directly against feature branches, not the develop branch. Okay, because we are in a team, we don't want to step over each other's toes. We're not committing and pushing to the same develop branch, unless you're not using Git flow policy. Each developer would normally work against their own feature branch, and the feature branch could represent like a work task, a work item, some kind of specific task that was given, a change that is expected. Or sometimes I saw in some organizations that the feature branch is actually developer branch, as in each feature branch represents a person, an employee, that has their own, dedicated branch. Sometimes it will be possible in case of feature branches that more than one developer would work on the same feature, right? So it's still possible. But it doesn't really matter. It's all up to debate. It's up to the policy decided by the organization. It's not too critical, right? It's whatever works best for your organization, right? Right. So, oh, right, and almost forgot. And we have the release branch, the yellow one, which is split from the develop branch, which would represent the current version, which is a candidate to be deployed to production. There could be like last-minute changes to this candidate. And when these changes are complete and approved and everything is ready, then it will be merged into the main branch. And that would mean that it is essentially deployed to production. And any changes that were from the, where in the release branch, that maybe changes that were done the last minute could also be merged backwards to the develop branch as well. Again, the hotfix branch is not, as you can see, it's not split from the develop branch. It's split from the main branch, right? Because as I said, this is reserved for use cases where the fix has to be as soon as possible. It needs to be focused specifically on a specific bug that is currently hindering production in some way. So it cannot wait. It cannot wait for all of these changes that would come along in the version currently in development. It needs to be from the main branch, split from the main branch, very focused changes and fixes, and then merged back to the main branch, which means it would be deployed to production. And any fixes done in the hotfix branch will be also back merged to the develop branch, so that these fixes will be retained in the next version that will be released. So I'll go over it again in a very high level. Main branch must always reflect what is on the production server. The develop branch reflects the current development in progress, the current version in development at the team or organization level, whatever the repository represents. The feature branch reflects current development at the individual developer or individual feature level. And a release branch reflects a pending release with possibly last-minute changes, and the hotfix branch reflects emergency fixes that must be pushed to production as soon as possible. Questions about branches? Anything? No? Okay.
I do not see any questions at all.
Cool. Okay. Then I'm moving on. So let's zoom in on this thing here and take a look at what a day in your life is going to look like once you start working with DevOps methodologies. With what your life looks like once you implement a development lifecycle, right? A proper development lifecycle for your database. So as I said, first step, you need to clone the repository to your local machine. In the Visual Studio, this is kind of what it looks like. You have this button here, which usually represents connections, and it refers to connections to source control repositories. Let's say Azure DevOps or GitHub or GitLab, whatever. You would clone that repository to your local machine, okay, to some kind of local folder. And then you have basically a copy of the repository on your machine. Once you're ready to start working, you would split branch, let's say from the develop branch, right? You want to start working on some kind of feature. So you split the branch from the develop, right? The develop, let's say, is your origin branch, and your new branch is this thing that looks like this. Let's say JR, whatever, add new column. And this whatever could represent something informative, like a Jira work item task, or I don't know, or maybe a work item in Visual Studio, or an issue in GitHub, whatever it is. It needs to be informative, okay? So that at a glance, when someone looks at the name of this feature branch, they would know what it is about in general, okay? So we create this new branch, and now we start working. The developers start committing changes. They work. They make changes, and once they are ready to commit those changes, they would go to either the Git changes screen, or in some cases it's called pending changes, right? And they would write some kind of informative message as the commit message. And this is very important, that this message will be informative, because these commit messages, that is what you would see in history, okay? So let's say you do some kind of development, you make some kind of change, you write a commit message. And when you do so, you need to write the message in such a way so that other developers, or maybe you yourself in a year from now, would look at this message and more or less know what it is about. What is the meaning of the changes inside of this commit. Stage. Okay, a few words about the stage thing. Stage means that you could potentially have multiple files changed since your last commit, right? And you want to select specific files that you want to include in your commit. You use stage to, put your specific files on a stage and say, these are the files that I'm presenting to you, and I want to commit to include them in this commit. Files that you do not select in your stage will not be included in the commit. Okay, so you could do that to, let's say, if you want to split specific files to separate commit messages maybe, or whatever. You could also click on commit all when you don't have anything staged, and Visual Studio would understand it as, yeah, okay, I'm staging everything, all the changes, and let's just commit all the changes. Next, when we are ready to upload all of our commits, we do a push. So there's a window, let's say in Visual Studio, called Git repository. Depending on the type of source control, it may have a different name, but the idea is the same. You basically push your commits, your pending commits. And once you do that, those commits are now at the shared repository, right? And that's more or less it, right? In terms of the ongoing development, your changes are out there, they are in the cloud. So once you do that the first time, now you enter a cycle, some kind of work cycle, okay? You perform the push, your first push, now you come back to your workstation after another day of work. You go back home, you come back next day, and you're ready to start working again on the same feature branch. Maybe this feature branch is also being worked on by other developers. And maybe in the time between your last push and now that you came to work and started working again, maybe new changes were uploaded, were pushed by someone else. So now you need to do something that is called a pull, which basically means whatever changes, new commits that are in the shared repository, I want to download them to my local repository and update it, keep it up to date. So now you pull the changes, you commit new changes of your own, right? Same as before. And now you push, again, your new changes. And this cycle of pulling and then pushing commits is also called a sync, which basically means you pull and then push. And this is useful for early detection of possible conflicts, if there are merge conflicts. And if there are, then usually the interface, the UI, will provide you tools for resolving these conflicts. It will show you the differences, and you will have to choose which version is the right one and take it from there. Once you finish pushing all of your changes and you're done basically with the feature branch, now you're ready to merge it. So you create a pull request. This is an example screenshot from GitHub. You go to, let's say, if you have recently pushed changes, you would have a button like this. It says compare and pull request for this branch, or you go to pull request and create a new pull request. Doesn't matter. You specify the branches, the source and target branches, and so on. So once we do that, we see something like this, where we can add description of what this pull request is about. And then there would be, normally there would be some kind of reviewer, maybe the product manager or the team leader, or the assignee that will be responsible for working on this pull request. And sometimes there are also labels to help people distinguish between different issues and different pull requests. And you could also have linked issues or linked work items in your also in your commit messages, but also in your pull request, where, let's say, for example, in GitHub, if you do something like this, right, it will detect automatically that 2106 is an issue number, and once the pull request is created, it will also be converted to a link, so that you will be able to click on that link and it will take you to the issue. On the other hand, the issue will be aware when someone opens the issue, it will be like, oh, by the way, there's a pull request linked to this issue, so there is a pending fix for this thing, right? So all of this integration and connectivity is very useful. So as I said, once the pull request is created, someone needs to review it and approve it, and when they do, they merge the pull request. And that's about it. So, and then the changes are merged into the main branch. So a few popular Git source control tools. There's GitHub that I mentioned. There's also GitLab and Bitbucket and Azure repos from Azure DevOps. And there are also non-Git source control, right? They're like TFS and SVN and source SVN or whatever it's called, I forgot. It doesn't really matter, right? It doesn't matter which one you choose. Normally, usually the organization that you're working with would already use some kind of source control. And the best thing is to work with whatever the organization is most familiar with and most experienced with, okay? The concepts are all the same, right? The core concepts, they're all the same. It doesn't matter what you choose. Just, choose something, okay? Go use some kind of source control. Doesn't matter which. I don't care. It doesn't matter. Why is it not moving? There we go. Okay. Moving on, CI/CD. So basic terms in the field of CI/CD. First of all, let's start with unit test. What is a unit test? A unit test is the most granular and basic level of tests. It is usually created per single function or method or procedure in our case. It works as some kind of state machine test. And what I mean by that is that there will be some kind of input, okay, that would go to this function or procedure, whatever, and based on that specific input, there will be some kind of expected output. And if the output, the actual output, fits the expected output, that means the test is successful. If it's not the same thing, then the test is failed. That basically, in high level, that's what it means. A unit test. A unit tests are an integral part of CI/CD pipelines. Essentially, they have to be automated by definition, and their main purpose is to immediately, as soon as possible, detect breaking changes. Because let's say, for example, you created some kind of store procedure which works okay, right? It works fine and dandy in production, everything is good. A few months from after that, maybe a year or 4 years after that, you already forgot about that old store procedures that you created a while ago. It works okay, it's part of your production, everything's fine. A while later, someone does, let's say, something else, some kind of change that is not necessarily even related to your store procedure. Maybe added a column to some table that happens to be involved in your store procedure. That store procedure is dependent on that table. And if the number of columns is changed, suddenly your store procedure doesn't work, even though it worked just fine until now. If you had a unit test for the store procedure to make sure that it works based on a set of tests, you would detect those automatically and immediately as part of your CI/CD pipeline. With that being said, it is difficult and time-consuming to design and implement unit tests. It's very, very, granular kind of work where potentially every single function and method and store procedure has its own unit test, or maybe even multiple unit tests. It's very time-consuming, understandable. I get it, but it's also very beneficial. So I would suggest to focus at least as a minimum. Focus on your core processes, on the store procedures and processes that are central to your business, where if they doesn't work, the business doesn't work, okay? At least create unit tests for those. In SSDT, for example, these unit tests would normally be created as MS test projects, and I'm not going to go too deeply into that. We don't have time. Ask your QA department about what that means. Usually they would know what it is because it's very standardized kind of project. Very, very common. Okay, next, what is an artifact? An artifact is a commonly used term. It is very simple, but it is very important to understand what it is because you will see that word a lot. And what it means is basically this. Let's say you have a project. Doesn't matter which kind of project, any project, and you build that project. What happens? What happens in the world of projects when you build them? Well, an artifact is created. That is the child of a build. That is the result. That is the output of a project. That the artifact. Okay. If you recall, maybe if you happen to have seen it sometime, let's say you have a Visual Studio project, any kind of project, and you build it, and suddenly there's a bin subfolder, and inside all kinds of files. Those are the artifacts. Okay. And these artifacts are used for deploying to some kind of target, let's say production, for example. These artifacts is basically what that package thing that you take from your build folder, from your bin folder, and you deploy it to some kind of target environment. In between, more stuff could happen, you know, if there are sophisticated processes and such, like tests and copies and whatever. But essentially, that is like the basic, right? The main points of what is an artifact. For example, there could be DLL files, executable files, MSI installation files, ISPEC, which is an integration services package. That is an artifact of SSIS projects. DACPAC, that is the artifact of SSDT projects. And there could be many more, right? So let's see how we're on time. Not too good. Okay. I'll do my best to do this quick. Right. So let's see an example. CI/CD pipeline. What is a CI/CD pipeline? What does it look like? So imagine some kind of trigger. Doesn't matter what kind of trigger. Something triggers the pipeline, the automation. It could be a pull request being merged. It could be a schedule, or it could be something manual, right? Someone manually activated the pipeline. Doesn't matter. Okay. The trigger activates a build. Your project is being built right now, and now you have. Hopefully, you have an artifact. You also have a log which describes, which contains the output of the build and whether it succeeded, and if not, then what are the errors, and so on. So let's say the build was successful, and now someone has to approve it. And they review the log, making sure that everything is green and everything is okay. And once they approve it and everything is okay, they activate a copy step, which copies the artifact from the build location to some place where it will be deployed. And that after the deployment, there will be some kind of automated tests, hopefully unit tests, or maybe something else. As a result of those tests, there will be some kind of log, some kind of output that says whether the tests are successful or not. And this cycle, this almost closed cycle, would basically represent, let's say, the automated CI/CD pipeline deployment to a test or a QA server. So again, someone would have to approve that whatever happened until now is okay. And now the cycle repeats, but this time for, let's say, a staging server. So the same artifact will be copied to the staging server, deployed to the staging server, tests will run, and there will be some kind of output to make sure that everything is okay. Someone approves the next step, and then the same cycle repeats, but this time to production server. Okay? And now the same artifact, notice it's the same artifact. There's only one build here. The same artifact goes through this journey across these different environments, and eventually it will reach production. This part at the top, this is what we call the CI, or the continuous integration, sometimes also called continuous build, also known as a build pipeline. This part is known as the continuous delivery part, okay, the copying part, where basically means take the artifact and distribute it someplace, okay, copy it someplace. And this part over here we known as the continuous deployment part, or and all of the CD part, which is both continuous delivery and continuous deployment, they both happen to be CD, that will be known as the release pipeline. Okay, so basic terminology of CI/CD and what it usually looks like. This trigger that I talked about, could happen in several spots depending on what happens with your source control. Let's say there's a pull request. Let's say there's a pull request which triggers the build pipeline, right? And let's say it is merged into the develop branch, and because it's in the develop branch, that means it will trigger a pipeline, a release pipeline, to deploy the artifact to a test or QA server or whatever. Let's say we also merge into the release or maybe the hotfix branches, and that would trigger a pipeline to a staging server. Okay. And if you have merged into the main branch, then another release pipeline will be triggered to deploy the artifact to your production server. Okay, this is for example, right? This is just an example. Each one of these spots could trigger similar pipelines, similar processes, but which one and which environment and which branch goes where, that would depend on organization policies and whatever the organization prefers and works best for them. Popular CI/CD pipeline tools, there could be Azure pipelines or VSTS pipelines, GitHub Actions, Bamboo for Mutilation, GitLab, AWS Code Pipelines, Code Deploy, Jenkins, Travis CI, TeamCity, Octopus Deploy, and many, many more. There's a whole host of automated CI/CD platforms, right? It doesn't matter. And again, as before, just ask your DevOps guy or team or product managers in your organization if they happen to already be experienced with an existing tool that they have. And if they do, then just join them, right? Get on board the same platform, simply so that it will be easier for your organization to onboard, okay? And so that they'll be in a familiar environment and have familiar tools that they will be already proficient with and know how to work with them. Okay, so we are very short on time, so I'm going to skim right through this part. And about SSDT, I'm not going to go too deeply into that. Just say that it is a free tool from Microsoft, completely free, totally and entirely, fully free. Okay, it is basically an extension for Visual Studio or VS Code to create SQL database projects, right? It also contains utilities such as schema and data compare, a very useful refactoring tool, and it has unit testing project types meant specifically for SQL Server databases. Okay, it's not your normal widely known unit testing MS Test project. It's some kind of wrapper around it, specifically meant for SQL Server databases. And for your DevOps guys, this slide is for your DevOps guys. Just let them know that in order to build this SSDT project, they need to use the standard msbuild command. The artifact, as I said, is the DACPack file. And in order to deploy DACPack files, you would either use SQL package command line, or you could also use PowerShell using modules such as DAC services or DBA tools. DBA tools specifically make it very easy to deploy using PowerShell. I strongly recommend that. And as I said, the unit test project type is a standard MS test, which can be executed using VS Test Console exe, at least as of today. And this slide is what your DevOps person needs to know. Because SSDT supports, it can be deployed, rather DACPack file, which is the artifact of SSDT, can be deployed both using command line tools such as SQL package and PowerShell scripts using DAC services and DBA tools. That means these two things. That means that every single CI/CD platform can support that. Okay, command line, PowerShell, everyone supports that. At least one or two of them, both of them. In Azure DevOps, there's also a GUI for that if you want, but I don't have time to go too deeply into that right now. Next, as a next step, I would suggest watching the second part of this series. The second session is called SSDT Methodologies for SQL Server DevOps, or methodologies and features for TV DevOps. Link on the screen, which is in my website. You will find all of the sessions there, a page for each session with links to recordings and such. Additional resources, I strongly recommend Introduction to GitHub for DBAs, which is a very good introductory session by Bernd Ozer to GitHub and working with Git. The Azure DevOps Duet by Kevin Chant and Sandra Stad, they have these sessions delivered in a bunch of platforms. There's a multitude of versions of this session, also very good. Sandra Stad has templates and starter scripts, very useful in his GitHub repository. Zero Downtime Database Deployment by Alex Yates is a very, very important session that I always strongly recommend. It doesn't deal specifically with SSDT or specifically with this kind of CI/CD or source control or whatever, but it's more high level than that and deals with how you would develop and how you would deploy changes to your databases when your databases are completely critical and they have to be fully available and there must be zero downtime, absolutely zero downtime, right? All kinds of tricks and methodologies, I strongly recommend that. And if you want to go a bit deeper into unit testing, I recommend unit testing with SSDT session by Andrei Zavetsky. He has a session recording on this on YouTube. And there's also Microsoft Docs documentation on SSDT and how to work in what they call project-oriented offline database development, which basically means you're working with SSDT locally as opposed to in a shared development database, which is, in case you didn't know, is an anti-pattern. And more resources are created every day. As I said, DevOps is getting more and more momentum, and there's more and more resources created every day about this topic in general and for SQL Server specifically. Thank you. I've been Eitan Blumin, and now it's time for question if we have the time. Kevin?
All good, but I do not see any questions out there for us. So sadly, y'all, if you have any questions, please be sure to put them in the chat.
I think they should also feel free to open their mics at this point and just ask whatever it is they want to ask if there is something.
So Power DBA class asks, any experience with T-SQL-T?
Yeah, I have a bit of experience with T-SQL-T. Sandra Stad, this guy, has even project templates that utilize T-SQL-T and useful script for that. T-SQL-T is not the same thing as the unit testing project type in SSDT. It's something else. It's more T-SQL and CLR oriented. Sure, you could use that as well. It doesn't really matter. Whatever, you find it easier for you. Yeah. Any other questions?
It looks like it. Yep. As of right now, that's the only questions we have.
I think someone said something.
Eitan, you mentioned deploying using DBA tools,
right?
But you also talked about DAC services.
Yes.
I don't know what DAC services are.
DAC services is the official module for PowerShell, published by Microsoft, which is used for deploying DAC files using PowerShell. DBA tools is in fact a wrapper for DAC services. If you open the source code for the relevant commandlets in DBA tools that publish DAC files, you will see that they use DAC services.
Okay, thank you.
They just simplify the work with it because DAC services is a very complicated sort of model to work with. It's very not convenient. So DBA tools makes it very, very simplified.
So the commandlets and DBA tools are going to be a little bit more intuitive then. Okay, thank you.
Yeah, by far. Yeah.
All right. Anyone else have questions?
I think that's it, right?
All right. So with that, I know obviously Ethan has this wonderful sign up on the screen to remember part 2 of the things that DBA should know for SSDT and Git and all kinds of other goodness. But
Right.
I'll also want you to remember that on April 11th is our next actual meeting of DBA fundamentals. We're talking with Andy Yoon on uncovering duplicate, redundant, and missing indexes. Always a good topic. So with that, thank you all for coming this week. Be sure to check us out on YouTube here very soon, where you can see this entire presentation if you ever want to refer back to it. And with that, thank you all very much. Have a great week, and we'll see y'all soon.
Bye, guys. Thank you.